Advanced Financial Modeling, VBA for Finance, Learning Objective number 4, for loops and an aggregation program. So in VBA, loops are one of the most important things you're going to learn. And loops or loop structures are used to execute lines of code repeatedly. In other words, if you needed to make a calculation that required 1,000 calculations, what you're going to do is you're going to use a VBA loop. Now, there are many loops in VBA. There are do-while loops, do-loop-while, do-until, do-loop-until, for loops. These are all ways of executing a line of code for a certain number of times. So, for example, if you want to do a do-while loop, you can execute a line of code as long as one condition is met, say a value is less than or equal to another value. But mostly in the programs I write for this course, say 95% of the programs you're going to see in this course, I use for loops. For loops are when you know exactly how many times you need to execute a statement. The do-while and do-untils, they allow you, the number of iterations are not known until the program is executing, and I'll show you examples later in the course. But for now, let's just say that most of the time you know exactly how many times you need to execute a statement, and that's a for loop. So I'm going to show you for loops. So here's a program called p-value. Okay, that function p-value has 3 parameters: payment, n, and r. N is the number of payments, payment is the payment amount, say the dollar amount, and r is the interest rate. So what this program is going to do is calculate the present value of n payments discounted at rate r. So n is the number of payments, payment is the dollar amount. So for example, what if you want to calculate the present value of 5 payments of $100 at a discount rate of 10%? Well, what the cash flows then look like are 5 cash flows of 100, and you're going to take 100 divided by 1.1. That's the discount rate. To the first power, that's 90. $100 divided by 1.1 squared, cubed to the 4th and 5th. So you're going to take the present value of all 5 cash flows and sum it all up, and that's going to give you the present value. So you can see in a spreadsheet how you could write that. So here's the cash flow payment divided by 1 plus r to the n year. And I sum it all up, and that's the present value of a 5-year annuity of $100 each period discounted at 10%. Notice I can also use the PV function. I put a negative sign in front of it because otherwise I get a negative value. And the PV function does exactly what we're trying to do here. The PV function, you put in a rate, a number of payments, and the payment amount. But how could I write a program that does something like this? All right, let's take a look. Let's see what this program's actually doing. So we can insert that program, by the way. If you go to your VBA, notice I already have a program called p-value there. And so you can just go to the spreadsheet, and let's go ahead and put p-value in there. So I'll just select fx, user defined. Let's try to find p-value. There it is. I'm going to insert that program. I can double click or just hit OK. And then I can put in the payment, the number of periods, and the R. And notice my program returns 379, which is the exact value. So it's a good thing I've tested this. I want to make sure it works. But let's go back to the code. Whoops. Let's go back to the code. So the code. Program's called p-value, 3 parameters. Here is the loop. For I equal 1 to n, next I. So this is what we would call the loop. For loops always start with a for statement and end with a next statement. In this program, I'm creating a counter variable, and I'm going to give it a name of I, which is, for most of my programs, I use a counter variable, and I usually call it I. So I is going to be the time period, 1, 2, 3, 4, 5. So here's how this program sets up to calculate those 5 payments in only 4 lines of code. So you say for I equal 1 to n. Remember, what is n? In this program, the user is going to put in a 5, so it's going to say for I equal 1 to 5. All right, so that tells the program how many times you're going to execute the line of code. 5 times. This is going to set the variable I to the first value 1. And then it's going to go down to the next line of code. P-value equals P-value plus the payment, that's the $100, divided by 1 plus the interest rate to the 1 power, since I is equal to 1. So what it's doing, it's calculating this $90.91, the present value of the first payment. So why did I put the name of the program back in here? This p-value. P-value initially is set to a value of 0. So it's saying p-value is equal to p-value, which has a value of 0, plus the present value of the first payment, which is that 90.91. And then it's going to go to the next statement, next I. What the next statement does is it kicks it back up to the for loop and increments the variable by 1 number. So I then goes to 2. So now I is equal to 2. And then it's going to execute this line of code. P-value equals P-value. Now, here's the most important thing here. This is going to create an aggregation of all these 5 cash flows. So when I run the program, when I run the loop for the first iteration, and it sets I equal to 1 and calculates 90.91. So it's p-value equals 0 plus 90.91. Next I sets I equal to 2. P-value equals p-value. Now what is p-value? Well, it's 90.91 plus $100 over 1.1 squared, $82. So the second time it runs this program, it says p-value is equal to the prior value, and the current value of p-value, 90.91, plus 100 over 1.1 squared, which is 82.64. And so now p-value is now worth about $173. Then it's going to do next I. It's going to come back to the for statement, set I equal to 3. It's going to then say p-value is equal to p-value, which is the $173 or so, the sum of the first, plus the present value of this third payment, 75. So you can see how this program works. Let me kind of give you an idea how the actual structure works. It's going to set I equal to 1, execute the line of code. Next I, set I equal to 2. So it's going to go through this 1, 2, 3, 4, 5 times, setting I equal to 1, then 2, then 3, then 4, then 5, and then executing this line of code. Now here's what's an interesting thing to think about. What would happen if I took this out? If I took that out, every time it ran the line of code, the p-value would just be equal to 90 the first time, then 82, then 75, then 68, then 62. And then when I ended my program, it would give me a value of 62, which is just the last value that was calculated in the loop. But by saying p-value equals p-value plus, it keeps adding to itself. So this is a very simple and effective way of aggregating cash flows, which is a very common thing in finance, is we take the present value of a lot of cash flows, not just the present value of a single cash flow. So that is the program. That's how we set up a basic for loop. We could have also written the program this way, and sometimes I'll see code written this way. Function p-value 1, payment nr, so same as above. And then a lot of programs will do this. All right, I used to do this when I first started programming, but I kind of stopped doing it. I try to write programs with a minimum line of codes now. So you could say temp equals 0. So new variable called temp equals 0. Do your for I equal 1 to n, next I, and say temp equals temp plus. So all I've done here is I've created a new variable temp, and then the present value of the cash flows are all inside temp. So temp winds up having the full present value of the 5 cash flows, And then the last line of code, p-value 1 equals temp. Now, why do people do this? Well, I'm not totally sure, but I think I have an idea. P-value, the present value of an annuity, doesn't become the present value of an annuity until it's completed all the aggregations. So let's just call temp kind of that temporary variable that I'm using to aggregate the cash flows. Once the loop is run its 5 iterations, then we say, well, p-value is equal to temp1, or to equal to temp. So sometimes you'll see it set up this way, but I tend to, in most recent years of my programming, I've dropped that notation and I just go ahead and calculate the function name right inside the aggregation, and I'll set up a temporary variable. So in this topic, we used for loops and aggregation programs.